Magnetic force on a moving charge. The electric charge moving in magnetic field experiences a force called Lorentz force, and it is given by F equal to QVB sine theta. In vector form, vector F equal to Q into V cross V. Direction of force can be found by using cross product rule, like if this is I, this is J, and this is K cap, then rule is I cross J equal to K. If you move in the direction of the arrow, you will get next one, the cross product of it. If you move in reverse direction, then you will get negative. Like if we find I cross K, then we will get minus J. So this is how we can easily get the direction of the force and its value. Suppose electric field and magnetic field both are present. In that case, force will be QVB sine theta plus QE. Now, in case of this equation, F equal to QVB sine theta, we can consider different situation. Suppose theta equal to 0 degree. It means magnetic field is in this direction, charge particle is also moving in this direction, or charge particle is moving anti-parallel to it. So in both the cases, because sine 0 degree is 0 and sine 180 degree is also 0. So in both the cases, F will be 0. When theta is acute or 90 degree, then what will happen? So suppose theta equal to 45 degree. In that case, force will be F equal to QVB sine 45 degree. And suppose we want to find out maximum force, then F will be QVB and sine 90 degree. It means if velocity of the charged particle is perpendicular to the direction of the magnetic field, in that case, we will get maximum value. Now, let's consider some numericals based on this concept. So, first question. A long straight wire AB carries a current of 4 ampere. This is long straight wire, it's carrying 4 ampere current. A proton P, proton is here. A proton P travels at 4 into 10 power 6 meter per second parallel to the wire 0.2 meter from it. This distance is 0.2 meter and in a direction opposite to the current as shown in the figure. Calculate the force which the magnetic field due to the current carrying wire exerts on the proton. Also specify the direction of the force. So if you remember, magnetic field due to straight current carrying conductor at a distance r is given by B equals mu naught I divided by 2 pi r. Since current is in upward direction, so here at point P, magnetic field will be perpendicular downward. And this proton is moving in this direction. It means both are mutually perpendicular. So field is along negative z-axis and proton is moving along negative y-axis. So let's evaluate the value of magnetic field first. We put the values. So 4 pi into 10 to the power minus 7 into current is 4 ampere divided by 2 pi times r, separation is 0.2. And this will give 4 into 10 to the power minus 6 Tesla. So we have got the magnetic field. And now in this magnetic field, the proton will experience the force, and force is given by F equal to QVB sine theta. Here theta is 90 degree, as I told you, sine 90 degree. We put the value. Charge on proton is 1.6 into 10 to the power minus 19 coulomb into velocity. Velocity is 4 into 10 to the power 6 into magnetic field. We have just evaluated 4 into 10 power minus 6. So this will come out to be 2.56 into 10 to the power minus 18 Newton. 2.56 into 10 to the power minus 18. Now let's consider another question. A solenoid of length 1.5 meter has a radius of 1.5 centimeter and has a total of 1500 turns wound on it. It carries a current of 3 ampere. Calculate the magnitude of the calculate the magnitude on the axial magnetic field inside the solenoid. Here it is of the axial magnetic field inside the solenoid. If an electron were to move with a speed of 2 into 10 power 4 meter per second along the axis of the current carrying solenoid, what would be the force experienced by it? Suppose this is solenoid. So we have to find, this is the axis. An electron is moving along the same line. It means magnetic field and direction of direction of motion of electron both are parallel. Field is in this direction, velocity is in this direction, so theta will be 0 degree. So force on electron, if we apply QVB sine 0 degree, so we will get 0. So second portion is clear, that there is no force if an electron were to move with a speed of 2 into 10 power 4 meter per second along the axis of the current carrying solenoid. What would be the force experienced by this electron? So from here it is clear that there won't be any force. Now let's consider magnetic field on the axial line inside the solenoid. So we know the formula for magnetic field inside the solenoid, B equal to mu naught Ni, where N is number of turns per unit length. So here length of solenoid is also given. So total length is 1.5 meters. So we can write N as capital N upon L. So it will become mu naught capital N upon L times I, and we put values. Mu naught is 4 pi into 10 to the power minus 7 into number of turns are given as 1500 here, 1500 divided by length of solenoid is 1.5 meter, and the radius has nothing to do with the magnetic field, into I. I is 3 ampere. So if we evaluate it, so we will get B equals 0.038 Tesla, which is our answer. Thank you for watching.